Hi everyone, this is Sangeeta working as assistant professor in IoT department. In this session, we're going to discuss about changes in the standard Ethernet. So the last session we discussed about Ethernet standard. Now we're going to discuss about the changes in standard Ethernet. The standard Ethernet suppose 10 habits per second. So where it gone through several changes before moving to higher data rate. The changes actually opened the evolution of the various standard Ethernets is based on higher data rate. There are various category of Ethernets are there: bridged Ethernet, switched Ethernet, and full duplex Ethernet. We will see the structure here. The first one is bridged Ethernet. In that bridged Ethernet standard, so the devices are connected in bus topology, which are the devices, the various junctions are connected by using bridge. So we'll see that the first one shows the devices connected without bridging. The second one shows the connection with using bridge. So likewise, the devices are connected. So here, this kind of topology also implemented in Ethernet standard. The next one we'll see there may be a possible of collision if we are using unbridged network. If we use a bridge network, we can avoid the collision. So like this is the important here. So what purpose we are using bridge means for to avoid the collision, we can use the bridges. Okay. The next one, we see that we can also use a hub topology, star-based topology. So instead of hub, we can use a switches. So the various switches are the several switches are connected in the standard Ethernet, and each switch have a connection with the separate device. So likewise, we can interconnect various domains on the switches. Okay. The next one we discuss about full duplex switch Ethernet. We know that full duplex communication means simultaneously we can send and receive the messages. Like so, here the same. But here the full duplex communication will be used. So the both is transmission and receiving both done simultaneously. So instead of hub, here also we are using switches. Okay. Next, we see fast Ethernet and topology. The fast Ethernet was designed to compete the LAN protocol with support the higher data rate when compared to the previous one. So when compared to the previous one, it support 100 megabits bit per second. So most probably FDDI connection, fiber distributed data interface connection will use this. The IEEE supports the fast Ethernet under the name IEEE 802.3U. So it's compatible with both standard Ethernet and fast Ethernet. So it is 10 times faster than the standard Ethernet. Okay. So next, we see the specifications under fast Ethernet. So the baseband signal will be used here also, but instead of the 10 megabits per second data rate, here 100 megabits per second will be used. So in that 100 base TX and FX and T4 will be used. 100 base TX means two wire categories of unshielded twisted pair will be used. If it is at 100 base FX, two pair of fiber optic cable will be used, and 10 base T4, four wire category of unshielded twisted pair will be used. These are all the three specifications here. Using a twisted pair, fiber optic, and unshielded twisted pair will be used. The next, the various categories here, the medium is unshielded twisted pair, or we can also use a shielded twisted pair in 100 base TX, and number of cables will be used as 2, and the maximum length is 100 meter, and encoding scheme 4 bar 5B encoding will be used. 4B bar 5B encoding will be used, and MLT3 based line encoding also used. Then 100 base FX fiber optic cable will be used. Two wires are used. 100 meter maximum length. Here also in non-return 0I line encoding will be used. In that 100 base T4 twister pair cable, unshielded category of 4 unshielded twister pair will be used. 4 pair cables are used. So here also the length is maximum length is 100 meter. Okay. The next generation is a Gigabit Ethernet. It supports higher data rate when compared to the first Ethernet. Support 1000 megabits per second. So here it's also specified the various implementation under Gigabit Ethernet, 1000 base if SX and 1000 base LX and 1000 base CX and 1000 base T, which means that SX is a two wired cables of shortwave fiber and long wave fiber, and copper cable will be used in shielded twisted pair, and unshielded 4-wire unshielded twisted pair will be used. Okay, so it's 10 times faster than fast Ethernet. Okay. The very summaries are fiber short wave communication and fiber long wave communication, and the short shielded twisted pair and unshielded twisted pair will be used. The maximum length of 1000 base TSX is 550 meter, and 1000 base LX is 5000 meter, and 1000 base CX is 25 meter, and 10,000 base T is 100 meter. So here it is also use a pair of cables in 1000 base T. So two pair of cable will be used. In both NRS encoding, line coding will be used. And next category is 10 gigabit Ethernet. It also specifies various specifications. 10 gigabit base X, 10 gigabit base L, and 10 gigabit base E. Short wave multimode communication. It's a fiber optic cable will be used, and long wave communication, and finally the extended long wave communications used. So here fiber optic cable will be used, the signal, the transmission of light. So multimode indexing will be used in shortwave communication. For long wave, the single mode transmission will be used, and also extended format also single mode communication will be used. So here it's 815 nanometer and 1310 nanometer, then 1515 millimeter. Okay. So these are all the various specifications of 10 gigabit Ethernet. That's all about various generations of Ethernet. Next, we will discuss about wireless LAN in next class. Thank you so much.